What am I actually asking you to do? Good, to find the value of x. So I could have, if I wanted to, put solve at the beginning here. So find me what I don't currently know, find me what the value of x is. Okay. All right, fine. So really what I'm asking about here are laws of indices or exponent laws. Okay. So if we look at the first one, we have 3 to the power of x times by 3 to the power of 2x is equal to 27. So, what do you reckon?
I get x plus 2x equals 27.
X plus 2x equals 27. Not quite. Not quite. I mean, why have you done x plus 2x?
Because like if we multiply,
Yep.
we have to add them.
Good. So you're multiplying two things with the same base, which means you have to add the powers. Good. Okay, so I agree with that. So the left-hand side should be 3 to the power of those two things added. And you've got 27 over on the right-hand side. Now, I'm not going to write down 27. Could you change 27?
3 to the power 3.
Good. Yeah, it is. Yeah, absolutely. It's just 3 times by itself 3 times. Now, why have I written 27 as 3 to the power 3? Why have I done that?
To be like all the bases.
Yeah, good. I need the base the same. So yeah, these numbers down here, they need to be the same. Okay, where could we go from here?
Then x plus 2x equals 3.
Yeah, good. Well done. So you're basically saying, look, I've got 3 to the power of something equals 3 to the power of something. So therefore, that means that x plus 2x is equal to 3. Perfect. Then what?
Then 3x equals 3.
Yep.
Then x equals 3 over 3.
Or 1. Perfect. Well done. Good. Yeah, so it's just about applying your laws of indices and trying to simplify it down as much as physically possible. Good. All right then. So what about the next one? We've got 5 to the power of x, all raised to the power of 3, times that by 25, divide that by 6 to the power of 0. And we know that has to come out as 125. Okay, any ideas?
It's the same 5x to the power 3
Yeah?
multiplied by 5 squared.
Good, well done. So you're basically writing that as 5 squared. All right, so you got 5 to the power of x. Could you do anything with this? 5x all raised to the power of 3.
5 to the power 3x.
Perfect. Just multiply those two powers together, don't you? Well done. So you've got 5 to the power of 3x times by, and you said 25 was 5 squared, divided by, could you do anything with 6 to the power of 0?
I think it's 0.
It's not 0.
1.
It's 1, yeah. It's anything to the power of 0 is always 1. The way which you can remember that is, okay, if I have 6 cubed, that's going to be 216, is it? Yeah, thank you. 6 squared, what's that? Good, 36. What about 6 to the power of 1? Just 6, perfect. So let's just see what's happening here, because then we'll be able to get 6 to the power of 0, right? Well, okay, to get from here to here, are you happy you've just divided by 6? Because you've gone from 6 cubed to 6 squared, so there's 6 there. And to get from here, you've divided by 6, right? So to get from here to here, following the same pattern, what's 6 divided by 6? It's just 1, yeah? So that's the reason why anything to the power of 0 is always 1. And that's a really good little check, a little thing which you can put on the side of your page if you're not sure. Okay, so we now know that that thing on the denominator is just 1. Now, can you do anything with 125?
5 to the power 3.
It is 5 to the power 3. Look, you're looking for base 5, aren't you? So it's going to be 5 to the power of something in all likeliness. And you can always just stick it in your calculator to work it out. But yeah, it's 5 to the power of 3. Oops. There we go. Okay, good. So we're here. Are you happy this over 1 I can just get rid of? Okay, because anything divided by 1 is just itself. Okay, so can I do anything with this? 5 to the power of 3x times by 5 to the power of 2.
X multiplied by 2 equals 2.
3x mul.
Is it
What do you do to the powers?
plus?
You add them. Yeah, so 3x add 2.
Oh,
Yeah.
Okay. And
Good. 5 to the power of 3x plus 2 equals 5 to the power of 3. And are you happy that now we're at the same situation as we were up here? You're just basically saying, well, look, 5 to the power of something is equal to 5 to the power of something. Those two somethings have got to be the same. So 3x plus 2 has got to be equal to 3. Okay, so what can we do here? How can we solve this on the home stretch?
3x equals 5.
3x equals,
Oh. 1.
yeah, good. Take away the 2.
And then it's 1 over 3.
Good, so x equals a third. So divide both sides by 3. Well done. All right, good. Let's have a go at the last question then. So 10 to the power of 4x times by 1,000, all divided by 100 to the power of x, has got to be equal to 10,000. Where should we go? So you're looking for base 10, aren't you, here? So we can leave that alone. 10 to the 4x times by 10 to the power of 3, you said. Okay, can we do anything with this 100 to the power of x?
Is it 100?
Yes.
100 x.
Good, but looking like we're looking for base 10, aren't we? So can you write 100 as a base of 10? 10 to the power of what gives you 100?
It will be like 10 to the power 2x.
Yeah, good, well done. So 10 to the power of 2, all raised to the power of x. Could you do anything with the right-hand side? Could you do anything with the 10,000?
10 to the power 4.
Well done. 10 to the power of 4. Good. Okay, let's try and see what we've got here then. Can we do anything with the numerator? Just focus on the numerator first of all. What do you reckon?
4x plus 3.
10 to the power of 4x plus 3. Well done. What about the denominator?
We could multiply the down with the 4.
No, I would actually just get rid of the brackets. Because you notice we've written 100 as 10 to the power of 2.
It will be like 10 to the power 2x.
Ah, okay, good. Okay, I see what you're saying now. Okay, 10 to the power of 4. So yeah, you're one step ahead of me. So what were you going to do with the powers?
We could multiply the down with the 4.
Not quite. What are we doing with these two things?
Dividing.
Dividing. Okay, so we've got 10 to the power of something divided by 10 to the power of something. What should we do with those powers if we're dividing?
Minus.
Yeah, subtract. Just like up here when we were timesing, we ended up adding the powers. When we're dividing, we end up subtracting the powers. Yeah, good, well done. So I'm running out of space slightly, so I'll continue over here. So if we subtract these two powers from each other, we'll get 10 to the power of 4x plus 3, subtract the 2x. And that should still be equal to 10 to the power. Can you simplify this power for me? What should we get?
2x equals 4 minus 3, then 2x equals 1.
Ah, okay, you don't know what you wanted, that's fine.
It's equal 1.
Yeah, good, excellent, hold on. So let's just set these two powers equal to each other. So 10 to the power of something equals 10 to the power of something. That'll give us 4x plus 3 minus 2x equals 4. Simplify this side, we'll get 2x plus 3 equals 4. And if we subtract 3 from both sides, we'll get 2x equals 1, which means x equals 1/2. Excellent, well done. Does that all make sense? Yeah, so no issues there. So really what this was for was a reminder of our laws of indices, making sure we can practice them, which you seem to be able to do really well. Yeah. Any questions about anything we've done there at all? No? Okay. These are all exam style questions. Okay, so any of these, this one, they could all come up in an exam. Yeah. You're less likely to be asked what is 10 to the power of 2, okay? Less likely to be asked stuff like that. You're more likely to ask more involved questions, stuff like this. Good, excellent.